Okay, Lewis. So if we just look at this, okay, I'm going to look now at converting these these z-scores into probabilities. Okay, so if we think back on the last video, we looked at cartons of milk, and the mean amount of milliliters in a carton of milk was 600 milliliters. Okay, and we also found out that this 610 milliliters lied one standard deviation above the mean, so it was lying here, wasn't it? Okay, so what's my chances, I wonder, of getting a carton of milk with, say, below 610 milliliters? Okay, so what I'm looking at is, what's my chances of getting a carton of milk below 610 milliliters? Okay, so this side is 610. So we know here is the mean, which is 600 milliliters. Okay, and this is one standard deviation below the mean, which is 10 below 600, which is 590. Okay, so all down here, what's my chances of getting, when I'm going to buy a carton of milk, what's my chances of getting below 610 milliliters? Okay, well, here's what we do. Okay, this whole this whole curve, normal curve, is 100%. Okay, and I think this side of the curve is 50%, and then the other 50% here. Okay, and what empirical rule told us was that the chances of getting, choosing part of the data that lied within one standard deviation out of the side of the mean was 68%, correct? Okay, so remember it was 34% either side of the mean. Okay, and we said all this side was 50%. So if I just add the 50% here to the 34% here, I get 84%. Okay, and that's my chances buying a carton of milk with less than 610 milliliters. Okay, I wonder what's my chance then of getting a carton of milk more than 610 milliliters. Wouldn't it make sense? 1 minus the 0.84. Okay, changing that into a decimal, because remember I said that's 1, okay, or 100%. Okay, but we'll just say 1 for argument's sake. So 1 minus 0.84, which is 0.16, or another way of saying it, 100% minus 84% equals 16%. So there's a 0.16 chance, or a 16% chance of me getting more than 610 milliliters in a carton of milk. Okay, based on the data we were given. Okay, so that's that, right? But that's only letting us find out if I'm right on one standard deviation or right on two. What if I'm in here? What if I'm 1.5 standard deviations above the mean? Okay, what's my chances then? 1.5 standard deviations would be actually 650 milliliters. Okay, so what's my chances of getting a carton of milk with less than 615 milliliters? So what's my chances of being in here? Well, so far we wouldn't know, because we can only get the probabilities or the percentages when we lie exactly on these standard deviations, because remember we know our magic numbers. 68% lie within one standard deviation, 95, and then 99.7. We can't really tell about the ones in the middle until now. So what we do is we use our log tables. Okay, so if I want to find out the chances, okay, if I'm on this side of the mean and I want to find out the chances of me getting less than 615 milliliters, well, I convert it to a z-score, which I have already, 1.5, and then I just look up on my tables. It's on page 36 and 37 of the logs, and all I do is I go to 1.5 in those z-scores. and it'll give me a percentage. It'll actually give me a percent. Well, it'll give me a decimal, okay, which we can change to a percentage. Okay, that's all we do. I'm going to give an example now in the book. Okay, so watch this. Okay, so here's the Z-score, 168. Okay, so what's my chances of getting less than, so this side of the curve, less than 168? So it's 1.68 of a standard deviation. Okay, so that would be 1 there, that would be 2 there, but this is 1.68. So what do? Well, we have a Z-score 1.68. We go to page 36 and 37 of our logbooks. We look for 1.68 and it gives us this number. Okay, so 0.95. If we change that to a percent, it's 95.35%. Okay, generally we don't. We let it as a decimal. So it's 0.9535. Okay, of a chance of me being in here rather than here. Okay, have a think about this though. What would my chance be of being in the white bit rather than this? Well, remember, we said this whole thing was 1 or 100%. Okay, so it would stand to reason if the whole thing is 1 and this green bit is 0.9535, well then if I just took 0.9535 from 1, I get this. Okay, and we come to that down here. If I'm on this side of the mean, but I want to get this bit over here as opposed to the bit going back, I find out that Z-score. Okay, look, find out that Z-score, and it's 0.80323, and I take it away from 1. Okay, because the whole thing is 1, the Z-score will give you the area to the left. Okay, if we want to find the area to the right, we just take our Z-score, the Z-score number when we convert it to a probability, take it away from 1, and we get our answer. Okay, so just to go back over that, if we're on this side of the mean and we want to find the chances, or the probability to the left of our line, our Z-score, we just convert that into our Z-score, page 36, 37. However, if we're on this side of the mean, but we want to find out the probabilities to the right, then we get the Z-score, we change it into our probability in the logbook, but then we take it away from 1. Okay, like that. And same over here. If we're on the left side of the normal curve, and we want to find out just a little bit to the left here, we do the exact same. We get our Z-score, we change it to, in our logbooks, change it to our probability, we'll take it away from 1. Okay, and the very last bit, if I want to find the probabilities within 2 scores, the first I look at this line here to the right side of the mean, okay, and I just get that Z-score. Okay, so that'll give me the area, or I suppose the probability of everything to the left. So I want the area of everything to the left minus this bit. Okay, so get the Z-score of this as step 1, and then I want to find the area to the right of 1.2. So what I do for that is I get this Z-score, I change to a probability, and then I take it away from 1. So if you look here, I got this, and I got its Z-score. Then I got this Z-score, got its probability, took it away from 1. So I had 0.8238 for here, 0.1131 for here, and then I took the small one away from the big one, and I'm left with that. So the chances of me being in this green place is 0.7107, or if we change to a percentage, 71.07%. Okay, it's not hard maths, it's just a bit of practice. Okay, we spend all next week practicing a bit of some next week, practicing a bit of this. Okay. That's it, Lewis. I hope it makes sense. Okay, it'd probably be easier if I did it in class, but we're just short on a bit of time. Okay, so thanks, Lewis.